Hey Steve, we just got your RCI 2995 DXN, and first thing is we looked at the list and started from the top. Fan motor noise, so we went ahead and installed DC to DC converter right there, where it not only isolates your DC supply from your fan, but it also gives you RPM control over here. You could adjust your fan speed. So that's gone. Second thing is we came around the bottom side and found this cable that was connected to the mic jack input. There's no shield around it at this end, but apparently it's connected to the line N connector. Right behind the switch, which is this one right there. So I don't know what's going on, but I did try transmitting, and I got a carrier with no modulation on AM. I got a noise on sideband, and I didn't get anything on FM, and on receive I didn't get anything either. I did find here the mic connector right behind the this plug here. It had the coaxial cable soldered onto it, but the solder job wasn't that great, and I think something there was shorting out, but we still don't know. Tomorrow will be another day, and we'll get more into it. It's late at night, so we'll leave the rest for tomorrow. But for now, the fan turns on, and there's absolutely nothing coming out of the speaker, no interference whatsoever. Hey Steve, we're down to the meter section, and we're here on the S meter. What's happening is the meter's open, the coil inside the meter's open, and you can see here your level, your signal level. Right now we're feeding a negative 67 dBm signal into the antenna jack. That should give us an S9 right here, and it's not. We put the RF gain all the way down now. As we put the RF gain up, we should see an S9 on the meter. And we're gonna do that. RF gain up, all the way up. As you can hear it, the signal's there, but there's no deflection on the meter. Volume down. And the RF gain, let's leave it up there. And we're going to see how the RF gain works here. That's full open RF gain. And as we lower it, we can see the level of the signal go down to 0. If I open up the RF gain, here, I'm going to put the volume up so you can see, you can hear. So what I'm going to be doing now, we have there the RF gain all the way open, and as we put the RF gain here down, this is going to go down, as you can see. So it's working fine. The reception of the radio, as well as here, if I reduce the input signal to the radio and I lower that from 67, you can see the signal starts to go down to 0. That's a negative 136. As we go up, we should have a full scale signal right there on the meter. So here you have your S meter. We're going to test it out for continuity or the resistance. Here we have a little standard old school analog meter. As you can see, it's in the ohm settings. And you see nothing. We're testing for continuity, and there's no resistance, totally open circuit. Well, we've taken apart the meter, and we've managed to find the coil feed, the spring coil feed. You can see it. Right there in the center of the screen. That's where the spring coil is welded onto the main bobbin. As you can see, we managed to put it back on there. So it's working fine. Now when you apply power to the meter, you have deflection. So the meter's good now. Now the meter is back in one piece and working, sealed with its tape. Alright, so let's assemble the radio again. Well, we've got the meters installed back in, as you can see. So now we move on to installing the rest of the stuff. And we got all the wires and illumination reflectors back on. Alright, Steve, now we're going to do a little test on the meter. We already installed everything, all the side hardware and power supply and all the good stuff. It's back to normal. Now, we're going to go ahead and put a test through. We're going to do a transmit test. A receiver test, I'm sorry. There's a receiver test. We're feeding an S9 signal into that. It's actually negative 67, so let's put it at negative 67. And that gives us an S9 signal, as you can see. Now if we lower the RF gain, or if we lower the transmitted signal, we'll also see that's at 100, about 100, negative 100. And as we go up, back to 67, we have our S9. Which, by the way, we just calibrated it, and it's this adjustment right here. The AM and FM S meter adjustment. Okay, now we're going to set the insertion point for the FM audio at the reference oscillator, and the input to the reference oscillator is right here, right there, and this trace goes to here, which is the input, the output of the audio amp into the reference oscillator. So we'll cut this trace right here, and we'll take the audio from here, take it to the jack out in the back, and then it's interruptible by the audio line N exclusively for FM, and the output of the jack will in turn come back over here directly to the reference oscillator. The reference oscillator is a couple of varactors that, when modulated, they create the shift in frequency, which hence frequency modulation. Alright, there you go. We have now put the insertion points for FM audio right here. It's been spliced right here, and the output from the onboard amp is here. So your audio goes out here, goes to the jack, and comes back in over here. And on the top side, we could see here our audio in is here. And our audio out from the onboard amp is here. It goes through that wire into this connector. And that's where the FM audio will be inserted from the processing. And when the 1/4-inch jack is not plugged in, it'll just be a loop. So you'll be able to use the front mic jack through the onboard preamp of the radio, out to the jack, back into the reference oscillator. Okay, we're done installing the FM audio input jack, which basically interrupts the output of the Asymod's preamp output, which is now not only diverted to the sideband but also to FM. So we're going to do a little test. We're going to sweep the audio band starting at 20 hertz. I'm going to go ahead and start transmitting. We have 10 watts there on the bird. And we're going to look at the audio. Here we're going to start sweeping. We're going to go up from 20 to about 7 kcs. You can barely hear it, but it's there. Now we're going to look at the that's 20 hertz. .300 hertz. 600. 800. 1500. 2500 hertz. 4500 hertz. 7 kilohertz.